Tyméle, and I'm back in my lab to tell you a little bit more about my PhD. So as I mentioned before, my PhD is all about producing tiny particles, which are called microparticles, and which consist of a polymer and a drug. So the polymer is encapsulating the drug, medical drug, obviously. And these particles are going to be used to treat diseases that have to do with blocked blood vessels, and these blockage in the blood vessels can create all sorts of problems, such as strokes, for example. So the aim of my PhD is to improve the way we treat these blocked blood vessels by using these particles containing a drug that will be injected into people. And the way I do that is using a very tiny device such as this one. So as you can see, it's very, very small. It's about 2.5 centimeter. You can see with my fingers how small it is. And this is what I'm using to produce these particles. And to be more precise, the way I do it is by using emulsions. So you might have heard of that word before, but basically there is a very common example in your kitchen of what an emulsion is. So if you think about a salad dressing, such as vinaigrette, when you mixed the olive oil with the vinegar, they do not mix because oil do not like water. So they do not mix, as you can see in the picture on the left here. But after shaking it, what you can see is droplets of the oil into the vinegar. So they do mix and then form these droplets. And this is basically what I'm using for my own PhD. And this is what I do in the lab. So basically, I'm also using an oil phase, which is going to be my olive oil, in which I'm going to dissolve my polymer and my drug. And I'm also using a water phase, which is kind of the equivalent to the vinegar. And instead of shaking it by hand, I used a very small device that I showed you earlier. And this is basically a close-up view of what's happening into my device, where I've got the water coming in and squeezing the oil, so the olive oil, for example, and producing these perfectly spherical droplets. And these perfectly spherical droplets are then going to be dried and produce perfectly spherical particles with the polymer around it and the drug encapsulated nicely in it. And this is what the particles look like. As you can see, they have different shapes, different morphology, and I particularly like this one because it looks like a football and that one looks like a golf ball. And later, I'll be testing these particles to make sure that they have all the correct properties and they are safe to be used in patients. I hope this gave you a good insight into what my PhD is all about, but for now, let's get back into the quiz.
Final round. This final round is biology.
We shall see.
Yeah, this may be the toughest round yet.
Oh my god.
Because neither of us are biologists.
Not really.
First question, final round. Name the process where plants convert light energy into chemical energy.
No.
Oh, Helena.
Photosynthesis.
Correct. Ooh. Second question, final round. Which famous scientist introduced the idea of natural selection?
No.
Oh,
Very close. Is it me?
yes.
Oh, sorry.
That's okay.
Are we?
Yes, you are correct. Ooh. You're both biology, you're on it, I tell you. Right. Question 3, final round. What is the human's body's biggest organ?
No.
Tyméle.
The skin?
Yes, you're right. What does an entomologist study?
Meow.
Yes.
Is it bugs?
Yes, insects.
I was going to say ants because ento,
Oh.
ants.
Final question for your final round as part of the biology section. And the question is, which bird lays the largest eggs?
Uh?
Yeah. Dunno.
I have no clue how you say that in English. I think it's ostrich.
Ostrich. Yes.
Yeah, that one.
How do you say it in French?
Autruche.
Right, so that's the final score for the entire quiz.
Mm.
Okay, so thank you for taking part in the quiz.